Hello, my lovely viewers and my dear students. Welcome to my distance learning session on Mathematics Made Easy channel. Today I have brought for you a video from Module 4, Right Triangles in Trigonometry, and this is the lesson Geometric Mean that we are going to be covering today. Now there are two parts to this lesson. We are going to be covering part 1 today, where the learning objectives would be to understand how to find the geometric mean of two numbers, and I'm going to teach you the technique where without a calculator you can also solve and find the geometric mean easily. Then we are going to look at some similarity criteria for triangles. So you already know from the previous lessons few of the triangles symmetry conditions and the similarity criteria that we have looked at, and we are going to connect them to geometric mean to solve problems. So let's get started. And before we go on, a kind reminder, if you like my video, if you watch my video and have not subscribed to the channel, kindly subscribe, as it serves as a motivation to make more and more videos for all of you. Okay, so let me give you the formula that will be used to find the geometric mean. This is a very easy formula. If you need to find the geometric mean of two numbers a and b, the rule is just to multiply them, a multiplied with b, and then take the positive square root. And if you want to do it without the calculator, the trick is to use prime factorization method to get the positive square root. So let's see in the slide next one how we do prime factorization method to get the positive square root and get the geometric mean of two numbers. Okay, so let's find the geometric mean of the numbers 8 and 10. This is the solved example, so I will just explain for you. So the rule is to multiply and take positive square root. So 8 multiplied with 10. Now the rule of prime factorization says you write the numbers inside the square root as the product of primes. So let's see, 8 can be written as 4 multiplied with 2, 10 can be written as 2 multiplied with 5. Now again, 4 multiplied with 4 gives you 16, and this 16 can be taken out because it's a perfect square. So square root of 16 is 4, so 4 comes out and inside you are left with square root of 5. You can simplify this without a calculator also, and then if you want to convert to decimal, you will just substitute the value of square root of 5 and get your answer 8.9. Now let me teach you the trick for 1a. This one let me do for you, and then you can try 1b later on with the same technique. So the prime factorization is what we are going to be now using. So the trick is to solve the question without calculator. So the geometric mean, the rule says multiply the numbers. So I'm multiplying both of them. And now I'm going to write them as product of primes. 5 multiplied with 45 is 5 times 9. So I will write 9. And then 9 is can be written as product of primes in the prime factorization as 3 multiplied with 3. So now because it's a square root, we can take the pairs. These are both perfect squares. That tells you that the number 5 can come out and number 3 can also come out. So 5 multiplied with 3, so 15 is the geometric mean of 5 and 45. 15 is geometric mean of 5 and 45, and I did the question without the calculator. The method which I used was prime factorization. So even you can try this question now, same method, and there's as such no need of using calculator. Okay, so let's now understand a very important theorem which can be used for solving questions on geometric mean connecting similarity. So here, first observe the figure. You are given ABC, a big triangle, and in this triangle, as you can see, angle C is 90 degrees, so it's a right triangle. And from that 90-degree angle, from that right triangle, you are drawing an altitude. So CD is your height or altitude for this triangle ABC. Now, if the altitude is drawn to the hypotenuse of a right triangle, so as you can see, because angle C is 90, so AB here is the hypotenuse or the longest side. So if it is the hypotenuse, then the two triangles which are formed are similar to the original triangle and to each other. So this CD, this altitude, is dividing the big right triangle into two parts. One is the small one, BDC, the other is ADC. Okay, so these two right triangles you've got because now the angle D is also 90. So what the theorem says, the two triangles that are formed, the small one and the little big one, are similar to the original triangle and to each other. So we've got three triangles here. You can see here ADC and BDC. These are the two triangles. So if CD is the altitude to the hypotenuse AB, of the right triangles in ACD and BCD. These two triangles are also similar. So both of them are similar to each other, and they're also individually similar to the original big triangle ABC. So that's the theorem. So you get actually here three pairs of similar triangles. So I will now show you how the question will come for your exam. Okay, so let's first see the question. Example 2. Write the similarity statement identifying the three similar right triangles in the figure. So you are given this big triangle FGH and you are given the altitude GJ, as you can see. So this GJ is dividing the big right triangle where angle G is 90 into two small triangles FJG and HJG. So this angle J is also 90, altitude is GJ. So definitely the last theorem that we saw in the previous slide can be applied. So all these three triangles are going to be similar to each other. So separate the triangle into two triangles along the altitude, then you can sketch each one of them separately. So just make sure that when you are making these triangles, when you're sketching these triangles, you take the 90 degree on one side so that you can see that angle J, and angle G are similar to each other. They are congruent angles, each of them being 90. So accordingly, you can write by the theorem that triangle FGH is similar to triangle GJH is similar to triangle FGH. So this is coming from the theorem, and these are all three right triangles. So now you can try yourself this question and this one, and I will show you when you do that, applying this theorem, the three triangles will be similar to each other. So you may get a question in your exam like a multiple choice where you have to identify the three similar right triangles. So let me just show you one question which is important and can come for your exam. Okay, so let's see two questions here. The first one where you need to find the geometric mean of the two numbers. So you are going to use for answer 2 the formula that I gave to you. So geometric mean of A and B is, remember the formula, square root of AB. So you take only the positive value. So here the first number is 9, the second is 15. So I just do the substitution. Now, because I am not using calculator, I have to use prime factorization. So we know 9 can be written as 3 multiplied with 3 and 15 can be written as 3 multiplied with 5. So I've just put in all those numbers and done the prime factorization. So you have written the numbers 9 and 15 as product of prime numbers. So here, because it is square root, so 3 in pair can be taken out, and 3 and 5 don't have pairs. So these are unpaired numbers. So they will stay inside the square root and the number 3 will come out. So this is 3 square root of 15. So your answer is going to be, okay, let's do answer 3 now. Which of the following triangle is similar to triangle JKL? So the bigger triangle is JKL. As you can see, angle K is 90. So your JL is your hypotenuse. And you have the altitude KM, which is dividing the big triangle, the big right triangle, into two smaller right triangles. So definitely we can apply the theorem which we just now did in the last slide, which says that all these three triangles are going to be similar. So we need to select all that apply. So means there can be more than one correct answer. So let's first see which is the 90 degree M. Angle M is 90. So JMK or KMJ, both ways the same triangle you are getting. So this one, I'm just highlighting with the red, is one triangle which is going to be similar as this angle is 90. So let's look at the options. JMK, yes, this is giving you a correct option. So A is going to be answer. MKL, no, it's not a 90 degrees, so B cannot be answer. Let's look at the next one. JKM, again not an answer. KML, yes. So I'm going to change color here for you. So this green one, KML. So look here that I'm selecting those triangle where the middle angle like M here is 90. So JML, yes, that's correct. LJK, LJK, no, that's just the big one. So LJK, what about this triangle? Is it similar? Think about it. Don't you think that JKL and LJK are actually the same triangles? Yes, so definitely they are also similar. So here the answer will be A, D and E. In fact, if I may say, triangle LJK. It is not only similar, but it is congruent. It is of the same shape, it is the same size. It's just a different way, LJK, of naming the same triangle, right? So this one and JKL are actually the same triangles. You have just changed the way of writing them. So they are congruent. Okay, so let's now solve an important multiple choice question. This kind of question can be asked in your exam. So select the similarity statement that identifies the three similar triangles in the figure. So it's a multiple choice, A, B, C, D. You have to choose the correct answer. So let's see. We can definitely apply the theorem because FGH is a right angle triangle at G. GJ is the altitude. It is dividing the triangle into other triangles. All of three of them are going to be similar using the theorem that we just now saw. Okay, so let's draw the three triangles so that it's easy for us to identify. So the bigger one first, FGH, the triangle which is given, G is 90, so I'm going to mark the right angle. Now this is similar to these small triangles. So as you see, angle J here is 90. So next to this G, we are going to have J for sure in the triangle. So JHG, JFG, these are the two triangles. So let's write them now. Again, we are going to have 90 degrees similar, and the other one also we are going to have 90 similar. So this point definitely is going to be J. Now let's write the other triangle. So I'm taking the bigger one first, GJH. So I can write G, J and H. So this is the next big similar triangle, and corresponding to this we have the smaller one, this one F, J, G. So F, J, G, the smallest one. So these are the three similar triangles. Let's see which option is matching. So first FGH, let's identify it is here, 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 not here. So this is not the answer. So the option which is matching, let me write here first. FGH is the bigger, is similar to FJG, is similar to GJH. And how did we write the similarity? Looking at angle G and angle J, both of them being 90. So definitely the answer which is matching here is C. All of them look similar, so be careful, don't do the mistake. This one is the correct answer. So that is how you solve the question. So that's all for the session today. Wish you all the best for your upcoming exams. And before you end from the video, let me remind you to like, share and subscribe to my YouTube channel. Put down if you have any comments or questions. I'll be happy to answer them for you. Bye everyone.